Today's lesson is on congruent triangle proofs. Okay, so congruency is a mathematical word, but it actually means exactly the same. Okay, so if I want a congruent pen, I'm going to want a pen that's exactly the same as what I'm looking at or what I'm choosing. So there's a lot of things that we do that with. All right, one of the things that we don't always have congruency is with people. Okay, unless you're identical twins, and even then you're not exactly the same. So congruency means exactly the same. And with triangle proofs, and this is what our learning goal talks about, is that there are 4 congruency triangle proofs. So part of the success criteria is recognizing side, 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 angle, angle, side, side, angle, side, and right angle, hypotenuse, side. So we're going to look at all those things today. So just write this down and we'll get started in our lesson. All right, so each one of these slides, it will have 2 each. So the first one is side, side, side. So I'm going to call this one side, side, side. So it means that 2 triangles are congruent if they've got exactly the same sides. And you can see here that this side is the same as that, this side is the same as that, and this side is the same as that. So if we were to label these, I'll call this A, B, C, and I'll call this one D, E, F. Because they're exactly the same sides, I would say triangle A, B, C is congruent. So this looks like an equals sign, but it's a higher level of equals. So 2 $5 notes equal a $10 note, okay? But they're not exactly the same. A $10 note is exactly the same as a $10 note. So congruency is a higher order of equals in essence, okay? Is congruent to triangle DEF, all right? And we put our reasoning aside, angle side. Now, I'm going to talk more about this proof nature of it. It's a bit different to what we've done so far in this course. I'll talk about how we set our proofs as well. But the first type of proof is that 2 triangles are exactly the same if all their sides are exactly the same. So that's called side, side, side. Now the next one is side, angle, side. All right. Now it's not just any 2 sides and 1 angle. It's 2 sides and their included angle. Okay. If that's the case, then we can use our proof system to, say if I label these again, I'm going to go A, B, C, D, E, F. Then I can say that triangle A, B, C is congruent. Remember that higher order of equals to triangle D, E, F, and my reasoning would be side, angle, side. Okay. Now remember, I'm going to reiterate that the angle is the included angle of 2 given sides. Okay. So that's the second proof. Let's go to the third proof. Oh, I wrote it wrong. So let's fix this up. This one is angle, angle, side, and this one will be, I'm going to have to write that one again. So this one's angle, angle, side. This one's wrong, so don't write that one down, please. I'll put the new triangle in. So angle, angle, side. Let's put that in. Angle, angle, side. Now this is like side, angle, side. That it's not just any 2 angles and 1 side. It has to be 2 angles and the side has to be the one joining them. So we've got 2 angles and the side is joining them. So if this occurs in 2 triangles, then we can prove that they are exactly the same. So I'm going to do the same thing. A, B, C, D, E, F. I'm going to say that triangle A, B, C is congruent to triangle D, E, F. And our reasoning is AAS, which means angle, angle, side. All right, now with the last one, I obviously didn't set up properly, is RHS. Now some people think of this as right-hand side, and it has something to do with it. What I'll do is I'll draw my proper triangle so I can prove this. And what they are is two right angle triangles. Now, they have to have the same hypotenuse, all right? And then they have to have another side. So I'll put this one down. All right, so this one means, what does it mean? This one means right angle. Now put 90 degrees, all right, because that's what a right angle is. Hypotenuse. And then it just side. Now what this means is that if you've got a right angle on both of them, and then they both have exactly the same hypotenuse, and then it doesn't matter which side, it could be here or it could be here, but if they both have the same side that is exactly the same, then we can say they're exactly the same. And in maths, we say exactly the same, we call it congruency, all right? So if I do the same thing and I call this A, B, C, and this D, E, F, I can say that triangle A, B, C is congruent to triangle D, E, F. And my reasoning is right angle, hypotenuse, and a given side that's exactly the same. Okay. All right, how do these look like as proofs? I've got a couple of examples and we're going to do it there. Prove the following pairs are congruent. Well, the first thing I've got to say is that this one is exactly the same as this one. So, and the question has given it to us. It won't always be given. Sometimes we have to work it out. But at this level, that's what we're going to do. So, what is the name of this side? Well, that one's just called AC, all right? And it's because of the A and the C that links them up. So I'm going to say AC is equal to FD, okay? FD. So this is setting up my proof. And my reasoning for this is that it's given. Both of them have these symbols that tell us that they're exactly the same. So I'm going to write given as my reasoning. So this is how we set up a proof. Okay, so it's a bit weird to anything you've probably done in this course so far. Now I know that CB is the same as EF, okay, because of the same symboling. Okay, so I'm going to write that down. CB is if I wrote BC, it's exactly the same thing. So don't worry about it at all. Is equal to EF, and that's also given in the question, all right? Given. And then the last one is this one. We're given that this line AB is the same as ED. All right, let's go for it. So AB is equal to ED, and that's also given because the diagram shows it to us. So this is how we have to set the proof up. We have to do this first line, second line, and that line. It doesn't matter which order you put it in, but you need to have 3 lines. And then we make a closing statement, okay? Therefore, triangle ABC, and that's because of ABC, is congruent, so our higher order of equals, to triangle, now this is DEF, right? DEF, and our reasoning is all the sides are the same, so we call that one side, side, side. Right? So this is a proper proof. It's a very different way of doing maths, but we do it this way. All right, I'm going to give you one more example, and then I'm going to be done with the video. Now this one, we can see that not all the sides are exactly the same. We've only got this side that's the same as that side, but we have some other information. It looks like this angle is the same as that angle, and this angle is the same as that angle. Oh, what proof could I use? I think I can use angle, angle, side, because there's two angles and there's the side that's joining them. All right, so how do we set that up? Well, I'm going to start with the side first. I'm going to say BC is equal to QR, and it's given because the drawing shows it. Now I'm going to go angle, and this is how I'm going to draw my angle. ACB. See how this angle starts at A, it joins at C, and that's B. So I'm looking at this angle here. So I'm going to go angle ACB is equal to ABC. Can you see how we do our angles? ABC, and now I'm looking at this angle. All right. I'm going to rub some things out. So I'm just looking at this angle at the moment, and the way I call it is angle ABC. So our angle that we're talking about is always in the middle, all right? And that's given. Now that's the same as the green one over here. So angle PQR, remember Q is always going to be in the middle, the angle we're talking about. And then angle PRQ. PRQ. Remember, what angle are we talking about? The one in the middle of what we say. And that's given. Now, we've done our 3 lines of working out, and now we make a closing statement. Therefore, triangle ABC is congruent to, and the reason we said it was A, B, and C is because of this. And this one's going to be a bit different. Congruent to, let me rub some of this out. It's congruent to, I'm going to call it PQR. It doesn't matter which order we put it in. PQR. And what was our proof? Well, it can't be side, side, side. We actually use angle, angle, side. Right? Hopefully that makes sense. Peace out.